All right. Hello, everyone, and welcome back to another Qubit by Qubit lab. Hopefully the last week being sort of off has been a good reprieve, a good bit of a break for everyone. You will notice the setup today is a little bit different, and that's because we have a pretty different type of lab. For the first time this semester, we will be taking a shift away from mathematics and going more into computer science. So doing some practice with Python, with programming, as that is the language that we're ultimately going to be writing programs for quantum computers in the second semester. To start off, though, we are going to have our usual slideshow just for the first little bit. Although after the slideshow, I'm going to switch over to Replit, which should be a website that you are familiar with from lecture. And then we'll go through some simple and then some more complicated Python examples to review the concept of functions in Python. So without further ado, let's get started. Quick program for today, we'll do our attendance quiz as usual. Then we'll do our pre-lab Zoom feedback. Instead of questions from last week, because I guess it's been 2 weeks, we've been off, we will just go over a few corrections from homework 7, and I'll be sure to leave some time if anybody has questions about those corrections. Then we'll do the core lab contents itself, which, as I said, is going to be on Replit. We'll do some live coding. You all are welcome to follow along as well. So when we get there, I'll explain how to do that. And then finally, at the end of the lab, we'll do our post-lab Zoom feedback back here on the Zoom call. So as usual, let's get things started with the attendance quiz. This should be old news by now. The password is 6720. This lab is lab number 2A. So go ahead, log on to Canvas, fill out the quiz. The 2 quiz questions for this week is asking a little bit about your background in programming. So this is just so that we can gather some more statistics on where people were coming from before we started teaching Python. So we're asking, did you know how to code before taking this course in general? And then specifically, did you have any experience with Python before learning it in this course? So go ahead, sign on to Canvas, use lab number 2A, quiz password 6720. Fill out the quiz to let us know what your experience level is like. And as usual, this quiz is not graded. There's obviously no correct answer to whether you learned coding or not, but it does count for lab attendance. So make sure you do fill that out. I will give about 30 seconds here, and I'll also open up the chat if anybody has questions or comments about Canvas. But then in about 30 seconds, we will get going with the lab. Did you miss anything important? You missed my opening spiel, which I practiced for hours and hours. No, you're fine. We haven't gotten to the lab content yet. We'll be practicing programming today, and you'll see what's going on. Somebody's asking, they don't see the lab quiz. Where should they find it? So as usual, I cannot see the student view on Canvas, but if another student could hop into the chat and just give some guidance on where that quiz should be in Canvas, that would be much appreciated. Okay, so why don't we move on? For the pre-lab Zoom feedback, so this is the same as always. I'll throw up a poll on your screen. So this is just asking, on a scale of 1 to 5, how would you rate your understanding of this week's content? So basically looking at the lecture, did you follow everything? Did it generally make sense? Yeah, give us a rating here. It looks like people are generally feeling a bit more confident about this than perhaps some other subjects, which is good. Cool. Okay. Thank you for that. So before we go on to this week's lab content, I'm just going to go over some corrections from homework 7. Now, a fair warning, I have not personally taken a very close look at homework 7. I just know about these correction questions, but feel free to ask any questions you have about the homework in the chat, and I will try to address them. So the first one was in question number 5. You are asked to fill in the blank. The program should ask the user to input how many seashells they collected. If they have 3 seashells, tell them to give 1 seashell to their friend. If they have less than 3, tell them to keep it for themselves. And here you are supposed to sort of fill in what goes in the if statement right here. Now, this question was corrected, so I'll flip over to the next screen to show what the correction looks like. It's pretty subtle, and to be honest, it's not a huge difference. But if you read the wording here, it's a little bit different. The program should ask the user to input how many seashells they collected. That's the same. If they have 3 seashells, tell them to give 1 seashell to their friend. Also the same. But then we just say, if not, tell them to keep it for themselves. So it's basically, there's only 2 possibilities here. Either you have 3 seashells or you don't. And those are the 2 possibilities you're asked to consider in the homework. The second correction, was on question number 7. So again, we're looking at the old version here. You're asked to print out this sequence 0, 1, 2, 3, 0, 1, 2, 3. So that sequence of 4 numbers 2 times in a row using 2 loops. And you're given this starting code with, again, 2 blanks to fill in here with conditionals on the loops. Now, as some of you, I should say, pointed out, this is not, well, as written, there was a mistake. It's not easy to do as written. And so the correct answer would be this. So notice the only difference here is we've inserted this line to set y equals 0 on every iteration of the outer loop. So with that change, you should be able to figure out this question and fill in those 2 blanks to get exactly this output. Okay, so any questions on those 2 corrections? I know that was pretty fast. But yeah, does anybody have questions on the corrections or just questions on the homework in general? I'd be happy to take those now. Okay, so if not, we will go on to today's lesson. So a really quick outline of the content. We have at the beginning a quick sort of mini lesson or review on functions. And so that'll be talking about how you write functions, how they behave in Python, that kind of thing. And then the bulk of the lab is going to be working on this mini project, which is making a calculator. So we'll be writing a bunch of functions that will do different functions, or that will do different things that you would expect a calculator to do. If we do have time, or as usual, I might go over time to cover the content, there is a second mini project to do Mad Libs. Some of you might be familiar with Mad Libs. If not, don't worry, I'll talk about it when we get there. But that's another project, I guess, that will just help us review some basic Python programming principles. So without further ado, I believe that's my last slide. Yeah, we're not at post lab yet. Okay. So here's the part where everything changes a little bit from before. I'm going to stop sharing my tablet and hop onto my computer instead. And we're going to do some live coding on Replit. So if you would like to follow along on your own computer, please feel free to do so. You can go onto this website, repl.it. You can see it in the top of my screen there. I'm hoping everybody can see my screen okay. Looks like it. Okay, good. Yes, so you can go to this website, repl.it, Replit. You do have to sign up for an account, unfortunately, which is a little bit sad. It used to be free to use, but yeah, you can just sign up for an account, and then it'll ask you what languages you want to use. You want to click Python, of course. And then you should be able to get to a screen that looks something like this. Now, my understanding is that everybody is familiar with this interface a little bit from lecture, so I'll just go over it really briefly. The basic idea is we write our code over here on this sort of middle panel, and then when we're ready to run our code, we hit the big green button in the top middle, and then it's going to show us the output of the code here on the right in the terminal. Okay, so let me just see if I can get chat. There we go. Perfect. Oh yeah, that's a good point. I guess people can't see the attendance code now. Yeah, didn't think of that. Sorry about that. Anyway, all right, let us move on with the lab. And if anybody does have questions, by the way, feel free to type in the chat. I have heard from other TAs that this lab goes by pretty quickly. So I am gonna try and take it slow just to make sure that everybody gets all the concepts, but please don't hesitate to jump into the chat and ask questions if you do have them. Of course, there are gonna be a lot of people here who have lots of coding background, and that's fine. There will also be people who have very little. So I'm gonna try and teach to sort of the folks in the crowd who are more beginners with programming, and hopefully going slow enough to accommodate that. So let's get things started with the function practice. So there's 5 basic questions here that we're going to go over, which will hopefully get everyone familiar again with function notation in Python, how that works. So here we go. First question. I'll read it out first, and then I'll start talking through the solution. So this question asks us to write a function named hair, which I know is a little bit of a weird name for a function, but anyway. It asks for a name and a hair color. So for example, if the name is Zeus and the hair color is dark brown, the function should print Zeus has dark brown hair. Call the function twice and enter with the name and hair color of 2 different students. So let's break this down into pieces. The first thing we're being asked to do is to write a function named hair. So if you remember from lecture, the way that we define functions in Python is with the def keyword. So I'll just start off with that here. You can see Replit handily tells me what I should be typing. So def is short for define. We're defining a function. And then you put a space, and next comes the function's name. So in this case, it's hair is the function's name. Now, just like in mathematics, the way that you describe the input to a function is in brackets. So here I'm going to start off with brackets. And we're told that we should ask for a name and a hair color. So I'm just going to call those name is our first variable, put in a comma, and then hair color is our second variable. And that's it. So you should notice that this notation looks very similar to if I wrote in math, f of x equals blah, blah, blah. F is the name of the function, followed by brackets, and inside the brackets is your inputs. So here, the only difference is we have 2 inputs. And as a general rule in programming, the function names and the variable names will be multiple characters. So we don't have to break everything down to just be called F and G and H. We can actually give them full names that are actual words in the English language. And so that's all we're doing here. We have a function name in brackets, the names of our 2 inputs. Now, to start off the function definition, we end it with a colon, just like that. And if I just hit enter here on Replit, it's automatically going to indent me on the next line. Now, indentation is the way that Python keeps track of what code belongs to this function. So if I write code up here, this all belongs to the function, but as soon as I backspace and put it without the indent, that code no longer belongs to the function. So indentation is very important in Python, and we'll be seeing more of it shortly. I had one question: when writing a function, do you always include the parentheses even if there is no argument? Yes, that is a great question. And so if I had another function that was called, say, I don't know, other hair, that is how I would finish the function definition. And you can even see on Replit, the text color was just black here. And as soon as I put the parentheses on it, it turns purple, which is the color of a function. So in this case, I would finish off my definition, nothing inside the brackets, colon to finish it off, and that's it. Okay, yes, so people are asking about the attendance code. You know what, I'm gonna maybe put it at the top of my file here. Access code is 6720. I don't know if people are gonna notice that, but thank you to everybody who's just throwing it in the chat as well. Okay, cool. So it looks like no other questions on functions. So we'll return to our question here on hair. Now, the way that we print things in Python is pretty straightforward. It's just the print function. So the way that you call a function is you just leave out the def keyword. So I'm going to type the function name, brackets, and then I'm going to pass it things as input. So what we're supposed to print here is name has name has color hair. So the first thing we're going to start off with is name. And then the way that we sort of glue strings together in Python is with the plus symbol. So I'm just going to do plus. So I'm going to take my name plus. Now we do has as sort of a middle part here. Then we want the color of the hair. So again, I'll just do plus color. And then the final word is hair. Right? So let's just review what we've written here. We should have print, in this case, if the name was Zeus, we would have Zeus has hair color is dark brown. So we'd have dark brown hair, which is indeed what we're supposed to print out here. Now let me just get rid of the other stuff that I've typed here. So if I just go ahead and run this, you'll notice that nothing happens. And the reason that nothing happens is because we have just defined our function. We haven't actually called it yet. And so in order to actually run this code, we need to call our function. And calling our function means giving it some inputs. So I'm going to hit enter again, and it's going to keep me inside the function. I'm just going to back out of it now because I no longer want to add my code to the function. And now I am just going to call it. So I'm going to try calling it with the example given in the question. So the name is Zeus. That's my first argument. And then the second argument is the color. So that would be dark brown in this case. And again, you're noticing that we just use these double quotes to indicate strings. Now, if I go ahead and run this, we should see something. And indeed, we get as our answer, Zeus has dark brown hair, which is exactly what we were expecting. To the question that was just asked in the chat, yes, def is just short form for define. So you're defining a function to be contrasted with calling that function. So let's do one more quick example. I'll do it for myself. So if I type in my name and I give my hair color, which is maybe not dark brown, it's just brown hair, I'll hit run again. And indeed, we have Zeus has dark brown hair as expected. And then we also have that I have brown hair, all as expected. So that completes our first question. We defined a function called hair using the def keyword. The content of our function was all indented, remembering that's the way that Python distinguishes code that's in your function versus code that's outside the function. And then we called it twice to make sure that it works. Now, a general comment or piece of advice, I guess, for coding, there is no penalty to hitting the run button as many times as you want. And so when you're doing assignments and when you're trying to code things yourself, don't spend too long just like looking at it and thinking about whether it's going to work. Just try running it. Try running it, and if there's an error, it will tell you, and hopefully that'll help you figure out what the actual error is. I think that's something that's pretty common to see in a lot of first-time programmers, is they don't want to run their code because it's like something bad will happen if I run the wrong code. No, like nothing's going to break. Everything here is just on your computer. It's not doing anything in the real world. You can hit run as much as you want. And that is honestly a really good way to test out whether your code works. So always feel free to just try running your code. All right. So just some quick questions. Sometimes when I do something wrong, Python throws me an error. Most recent call last something. I'm not sure what that would be. I'm not sure if anybody else in the chat might have an idea. perhaps if I come across the error as I'm working here, we can talk about it. But if not, I would encourage you to actually copy and paste the error into a post on Piazza, and then we should be able to help you out there. Now, Michael says you could cause an infinite loop here. So right now we're not working with any loops. We just have a function defined and then we call it twice. So there shouldn't be any possibility for doing an infinite loop here. All right, I am going to go on to question number 2. Oops. Let's try that one more time. Oh, not here, but for testing code. I see, yes, good point. So that is one thing that can happen, as Michael is pointing out here. If you have an infinite loop in your code, and by the way, an infinite loop just means you have a loop, right? Like a while loop, I believe has already been learned. And the condition that causes it to keep repeating never becomes false. So you always just keep repeating that code forever. Now, I believe what Replit will do is it will eventually, what we say is time out, which means it has a timer in the background. And if nothing changes, like if nothing gets printed out or nothing happens for whatever it is, 10 seconds, 30 seconds, something like that, then it will stop your code because it knows something must be wrong. So if you see your code just not doing anything for a very, very long time, you might have an infinite loop. Okay, so let's look at question number 2 here. Write a function named prod that takes 2 parameters, x and y, and prints their product. For example, if you input 2 and 3, it should print 2 times 3 equals 6. So this is a very similar type of problem. We're going to start off with the def keyword to define our function. It's called prod. Again, brackets to indicate our arguments here. Takes 2 parameters. So we have x, comma, y. And then remember, we always have a colon at the end of our function. And now Replit has indented for us, so we know that we are inside the function definition. The first thing we have to do is compute the product. So I'm going to make a new variable and assign it to x times y here. And then we're supposed to print the result. So that's this very similar idea from before. So we're going to say print. I'm going to start off with my x variable, and then we have a time symbol in between, y variable equals, and then our product. So just to review, we calculated the product, store it inside a variable, and then we're going to go ahead and print out the result. So as usual, I'm going to back out of my function definition. I'm going to try calling this. So the example they give is 2 and 3, just like that. And I'm also just going to comment these out for the time being. Oops. I don't know why this coloring is happening, but anyway. Okay, so I'll go ahead and run this. And you'll see that it gives an error. So this is our first example of seeing an error happen. Now, these error messages in programming can look really scary. I totally agree with that. But I promise you that just taking the time to actually read them line to line, it's okay if you don't understand some of the lines, but actually take the time to read them and try to figure them out. Don't just get scared away. Because often what happens is it'll give you 5 different lines or possibly even more. And there's really just one line that you need to read to understand what's going on. So let's start here. Starts off with traceback, most recent call last. No idea what that means. Cool, let's move on to the next line. File main.py line 17 in module. So some of this I don't understand, but I do know that we have a file called main.py. I didn't mention that, but that's what that's what Replit automatically calls your file. And it's telling us the problem is at line 17. So I go here, problem is at line 17. Okay, so it doesn't like that we're calling prod. And indeed, it prints out what line 17 is, so that's okay. And then we have another thing that says, okay, now go to line 15. Okay, go to line 15. That's where we print out the product. Okay, so there's something wrong with our print here. And then again, it just tells us what that line was. Now we have a type error, unsupported operand type for plus, int, and stir. Now, this is certainly a little bit of a mouthful. What this is talking about, though, it's talking about the types of the things we're adding together. So if I just look here, what do we think the types of all of these variables are? Well, the x we've passed in here is an integer. And so oftentimes in programming, integer will be shortened to int. And then this piece that I've typed out here is a string. We know it's a string from using those double quotes. And so we can see what it's having a problem with here is adding an integer to a string. It doesn't want to do that. What we want to be doing is we want to be adding strings. Just like we had in the hair example, adding strings means just gluing them together. And so the solution in this case is to convert our integer to a string and then have it glue those strings together. And the way we do that in Python is, if my thing would respond here, we do str, which is a short form for string. And then we pass x as an argument. Now, if I just mouse over this or click on it for a second, we can actually read what this function is doing. It says it's going to create a new string object from the given object, which I guess is pretty straightforward. It's going to create a new string for us from the x variable that we pass to it. So we give it an integer, it spits out a string. Now, if we are thinking, we might realize that this same problem is going to come up with y as well as product, because all of those are integers. So I'm just going to go and call stir on all of those variables. Now, if we run this again, we see the expected output. 2 times 3 is indeed 6. Okay, so we can do one more test just to make sure this works okay. I'm going to do maybe 4 times 5. Click run. And indeed, 4 times 5 is 20. All seems to be working. Now, one quick question. If you make a while loop with no delay to print something out, will the program crash or does it eventually stop? So one of my favorite parts about programming, honestly, is every time you have a question, probably the best thing to try is just doing it yourself. Actually write it down and see what happens. So I'm going to go ahead and do that. The question was, if you make a while loop with no delay to print something out, will the program crash or does it eventually stop? So I'm going to do while true, which is something you should probably never be doing in Python, but I'm going to create an infinite loop here and we'll print something out. Just like that. So let's see what happens if we run this. So as expected, we get lots and lots and lots of infinite loops being printed out. And if I keep waiting, it doesn't really seem to show any sign of stopping. So perhaps this would stop if I left it long enough. But if you see something like this, where you're just getting tons and tons and tons of output, chances are, again, you've got an infinite loop somewhere. And so the nice thing about Replit, you can actually just click where the run button was. It's now a stop button. If I just press that, it's going to stop it for us and no harm done. So again, it's always okay to run code. You can probably crash your computer like that. You should not be able to crash your computer like that, hopefully. The worst that would happen is that you just have to hit the stop button on Replit. Okay, let's go on to question number 3. Now, this is actually just a sort of like theoretical question. We're not going to write any more code for it. The question is, what are the parameters in this function? So parameters is just another word for inputs or variables, or sorry, not variables, just another word for inputs in programming. And so this actually goes back to a question that was asked earlier. If you had no inputs, that's what we see here. We just have brackets with nothing written in between them. That means there's no inputs. And so indeed, there are no parameters in this function. Let's do another question. Again, we're not going to have any actual coding here. This is just a theory question. So the following function has a bug in it. What is the bug? So I'll give you a second to look at this. I think we've already pushed home a lot of these points though. The student earlier asked, do you need brackets if there's no inputs to your function? Here we have no inputs either. And so we should have brackets always at the end of our functions. Doesn't matter if you have inputs or not, you always need the brackets there. So let's take things up a level and do a more complicated example. So this is another question where you're asked to find the bugs. The following function should return the difference of two numbers, find the bugs. So for this one, I'm actually going to throw up a Zoom poll, and I'm going to get all of you to do it for me and see if you can spot all of the errors. There is more than one error in this function. And so the poll that you see on your screen right now, you can enter multiple answers on it. So check everything that you think is a mistake with this function. And I'm telling you right now, there are multiple mistakes. I'll give a few minutes for or maybe not a few minutes, I'll give 30 seconds or so for everybody to take a look at this function, figure out what you think the mistakes are, fill in the Zoom poll, and then I will talk about it afterward. What is the password for the quiz? The access code is 6720. It's right there on the top of the file here. Okay, so I know there's still a couple of people who are still going. I'm going to start talking through this though, just reading sort of from left to right, top to bottom. So the first thing that it looks like many people did spot is this keyword here should not be ref. Ref doesn't, for our purposes, mean anything. It should be def, to define a function. So I'm just going to fix that there. Now we have def difference. Okay, now we have a space, and I'm just comparing with functions I've already seen before. That's often a good way to check code, is just go literally character by character, see if there's any difference. So we have def, we have our space, we have the name of our function, difference, all looks good so far. We have our brackets, that also looks good. Now we're supposed to take two numbers as input. So we have x, comma, and then closing bracket. So it certainly seems like we should have a y in here somewhere for the two inputs. And if you look at previous examples of functions where we had two inputs, like for example, the prod function here, we always had a comma in between them. So I'm going to go ahead and put y as the second variable, the second parameter for this function. Okay, so now this is looking a bit better. We have our colon at the end, so that is also correct. Now, the first line looks good to me. And so that should eliminate quite a few of the options in the Zoom poll. For the second line, we have that diff is equal to y minus x. Now that certainly seems pretty good. I mean, if I look at my product function, which is doing something very similar, again, the first line is, product equals x times y. Here we have diff equals y minus x. Now you will notice that replit is actually underlining this for us, which is going to give us a hint. It says the local variable diff is assigned to, so we give it a value, but it's never used, which is a good point. We don't actually do anything with diff here. Up here with product, we printed it out, and so we used it. But here, we haven't actually used the variable diff. So there's a couple of ways we can fix that. What we want to be doing here is we want to return the difference of two numbers. So I could add a new line here and say return, which remember is a keyword in Python that means give this as the output, diff. And you'll notice as soon as I do that, the underline goes away because now we have used diff. That was not the answer that was in the Zoom poll though. In the Zoom poll, it suggested that we could just do this. Return y minus x, and then get rid of this line. And indeed, this will work too. You can pass, it doesn't have to just be a single variable that you return, it could be a complicated expression of variables as well. And so this was the final answer I was looking for in that Zoom poll. Okay, so that brings us to the end of our function review. The next thing on the agenda is the calculator project. Before we move on to that though, does anybody have questions? So 3 errors in total then. Yes, good point. So the first error was that ref should be def. The second error is that we should have had a second parameter y. And then the third error is that we should have returned y minus x instead of just assigning it to a variable. Can you please put the Zoom poll so we can see what we got right and wrong? Oh, I'm not sure if I can still see. Oh yeah, maybe we can. There we go, yes. So there's the results. You can also see the relative proportions of people who saw everything. So here the correct answers were ref should be def. Inside the brackets should read x comma y. And then it looks like the one that a lot of people missed was that the last line should read return y minus x. Oh, people don't see it. That is interesting. It is right here on my screen. I'm not sure then. I am screen sharing. I thought I was screen sharing my whole screen. Okay, well, I did say them out loud verbally. I'm not going to take too long to try and fix that, but there were 3 errors, as was pointed out, and they were that ref should be def, add y as the second parameter, and then return y minus x. Yeah, it could be. I'm not 100% sure. Okay, so why don't we move on to the, oh, actually, I hit share results. Can people see it now? Ooh, fancy. Okay, great. Cool. Yeah, so those are the results. Hopefully you can all see it on your computers now too. All right, so let's move on to the calculator project. So again, I'm going to go ahead and copy paste some code. And then we'll get started on this together. I'm just going to get rid of everything we had here just to kind of clear space, but I will keep the access code up top. And this is what we're given to start off the calculator project. So we're given some functions, and these all look good. Actually, there's a typo here. I'll just fix that. So all of these look good. Def addition, it returns x plus y. Now this one's a little bit interesting. Def addition loop. So obviously the simplest way to do addition is just to return x plus y. But now in this loop, we're doing a for loop for I in range 0 to y, which means if I just write this out explicitly, I will take the values 0, 1, 2, 3, blah, 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 and then it'll go to eventually stopping at y minus 1. So I will never actually equal y in this loop. And for every time the loop executes, we're going to add 1 to x. Now, there is one other thing that is missing from this function, and it should be, it's one of the things that was missing from question number 5 that we just did as well. We actually need to return, in this case, x as the final answer. So if we just walk through a simple example with this, if I have, say, x equals 3, y equals 2, 3 plus 2, we expect to be 5. So let's just walk through how this code works. X starts off as 3. Now, I, for y equals 2, is just going to take the values 0 and 1. Because remember, when you write this range thing, it stops at right 1 before y. So when I is 0, we're going to take x, which is 3, add 1, so x is now 4. Then the loop goes a second time when I is 1, and then we add 1 to x again, so x becomes 5. The loop is finished, we return x, 5 was the answer, so this all looks good, even though it is a little bit of a weird setup. So let's go on to the actual questions we're being asked. First, it asks us to write 2 functions for subtraction that take input x, y. The first function is simple subtraction, and the second one needs to incorporate a for loop. So it'll be a very similar idea to what we saw here. Let's start off with the simpler case first, the first function. So this is going to be a subtraction function. I'll define space subtraction. And then we have our brackets. We are told in the question that we should take inputs x and y. So remember, it's x comma y. Always end it with a colon. Now, what do we need to do? We need to return the difference between x and y. So looking at how the addition function is written, it'll be something very similar here. Return gives us the output of the function, should be x minus y. And so far, that looks good. Okay, next up, let's do our subtraction loop version. So again, just to follow the convention from up here, I'll call it subtraction loop. Again, we're taking 2 variables, x and y, always end it with a colon. Now, for the function itself, how are we going to do this with a for loop? In the addition loop, the way to think about this is we started off with our value x, which was 3 in our example, and then we did a loop y times that incremented x by 1 every time. So it's kind of like saying, if I start with 3, I need to add 1 to 3 2 times to add 2, which again is a very convoluted way of saying it, but really we're just repeating the addition of 1 2 times. When we're subtracting, what do we want to repeat 2 times? If we were doing 3 minus 2, we would want to do x minus 1 2 times. So I'll follow a very similar structure here. We'll do our for loop. So it's for I in range 0, y, colon. So just literally reading off that exact same line. The only difference now is for every time this loop goes around, we're going to subtract 1 from x. That's the end of our for loop. Now we can go ahead and return x, and we should have implemented subtraction successfully. So actually, before we go on to this multiplication example, why don't we take a second to write some tests? Probably should have done this at the beginning, to be honest. But let's do our tests. So first of all, we're testing out addition, which is the first 2 functions we had. So it's going to print out the word addition just to label where we're at in our testing. This print with nothing inside of it just does a new line, so it's a visual separator. Now, we have some new syntax here, or potentially new syntax. We're using this function called input. Now, input is a handy function in Python, and it does a bunch of things at once. It's first going to print out the string you give it. So in this case, it'll print out input a number 1 to 100, colon, and then it'll put the user's cursor right at the end and wait for the user to type something in. So in this case, I could type in, 3 maybe as my x value. Then once I hit enter, after typing that thing in, it will assign the value to x. We do the same thing for y. Then we're going to call our 2 functions. So sum1 is going to be from our first addition function. sum2 is going to be from our weird for loop version. And then we're going to print add that, x to y. And then we're going to print out whether these two sums agree, whether they equal the same thing. So as usual, the best way to test this is just hit run, and then we will see what happens. I just saw there was some discussion. How do you highlight and comment out big chunks of code? Yeah, good question. So this is definitely not required content, but just for your information, the way you do it is you highlight everything that you want to comment. So in this case, suppose I wanted to comment out this whole function. I'm on a Mac, and so the keyboard shortcut I use for this is Command/. So if I just hit Command/, it automatically comments out all of those lines. And then I can hit Command/ again to uncomment them. So it does this sort of toggle on and off. Yeah, on a PC, it would be Control/, but you definitely don't have to know that. It's just a trick if you are curious. Let's return to our testing. I'm going to go ahead and hit run, and we'll see what happens. So as expected, it printed out addition and then a space. So again, that was our print addition, and then our blank print statement just does a space. And then this input statement is next. So as I said, it's going to print out this string. So input a number 1 to 100, colon, and then it puts my cursor right at the end here, and it waits for me to enter in a number. So I'll do our 3 + 2 example here. I'll enter in 3, and as soon as I hit enter, it's going to take the value I input and assign it to the variable x in my code. So I hit enter, now x equals 3. The next line was another input statement. So again, it printed out this string. It's going to wait for me to type in an answer. So here I will do 2 just to follow the same example. And I will hit enter. Okay, so we get an error. Now, if you look at this for a moment, I'll give everyone just a few seconds here to do what I said before, read through every line and try to identify which lines you understand. So the traceback, this always appears when you have an error. File main.py, line 32. So there's something it doesn't like about this addition loop. And then we have another error, line 9, an addition loop for I in range. So it doesn't like our for loop. And then the line that is going to help us the most, stir object cannot be interpreted as an integer. Okay, so clearly it's trying to interpret as an integer some string object. Now, the only variable that we're passing in here is y. So my best guess would be that y is in fact a string here when it should be an integer. So there's a few ways to fix this, but I think the most obvious way is using the stir function that we learned before to convert, or I'm sorry, that would convert from an integer to a string. Here we want to convert from a string to an integer. And so the answer is actually very similar. Instead of using the stir function, we're going to use the int function to convert to an integer. So down here, I'm going to reassign our variables. So for x, I'm going to set x to be equal to the integer of our string x, and y to be equal to the integer of our string y. So this is just going to convert from strings to integers. Let's run it again and see if it works. So I'll input my 3, 2, and now it's not liking it again. So now it's saying can only concatenate stir, not an int, to a stir. Now, if I look at the traceback here, now the issue is in line 35. And so indeed, what's happening here is it's now trying to treat this x and this y as strings. So we don't want any of that either. Here, the solution is just what we saw before. We call the stir function to convert these integers back to strings. So hopefully that will work this time. I'll hit run again. Our two values are 3 and 2. And this time it seems to have worked. So once we did all of this, it printed out add 3 to 2 in this case. And then the final line, print do the sums agree? True, yes, they do agree. Now, I just saw somebody writing this in the chat, and you're absolutely right. There are multiple ways to solve this problem. One of the tricky things about it, though, is when you pass x and y into these addition functions, they need to be integers. But when you print them at the bottom here, they need to be strings. So even if you had them as integers right up here, and then you didn't need these two lines, you would still have to convert them to a string down here. Hopefully that's clear. Okay, let's do this again and look at subtraction this time. So here I'm going to print ourselves a blank line just to separate things. And then just like in the addition example, we will give ourselves a nice title just to see what's going on. Another blank line. And then we'll do largely the same thing. So actually, I'm just going to full on copy paste what was going on here. Again, for subtraction, we want to get an x and y value from the user. But this time I'm going to have diff1 equals subtraction xy, and diff2 equals subtraction loop xy. So again, I'm just following very similar format to what we had up here with addition. And then for our print, I'm going to say subtract. So here we'll do stir x minus stir y, just to show what operation we're doing. And then we'll print out whether our two results agree. So diff1 equals diff2. Okay, so just for the time being, I'm going to comment out our addition test, just so we can run the subtraction test. So same idea. I'm going to do the same example, 3 and 2 here. So we have 3. Oh, my replit seems to have disconnected. Can everybody else still hear me okay? Okay, interesting. All right, seems to be back now. Not sure what that was. Okay, so I'm just going to rerun it to make sure that everything is working. We're going to try 3 minus 2. And here we see that it should be subtracting 3 minus 2. And indeed, the results agree. Now, just to be clear, I don't have to type in 3 and 2 here. I could do 99 minus 77, and everything should still work as expected. So the last part of this little assignment is to do multiplication. So I'm going to go ahead and paste this in. Oops. So again, very similar idea. Write two functions for multiplication. They take the inputs x and y. First function is simple multiplication. Second function needs to have a loop somehow. So let's do the simple version. By now, this should be fairly routine. Def to define a function. We're going to call it multiply. And then we take two input arguments, x and y. Always end the line with a colon. Now, here we just need to return x times y. That should be the result we're looking for. Second function is going to be multiply loop, which again takes x and y as inputs. But here, again, we have to do something with a for loop. So if you think for a minute about what multiplication is, you might have heard this before in math class even. Multiplication is repeated addition. Okay, so I'll say that again. Multiplication is repeated addition. So what we want to do here, if we have x times y, we want to add x to itself y times, right? And that should make intuitive sense. If you have x times y, what you're doing is you're taking x, y times, and adding them all together. So that's what we're going to do here. I'm going to start off my for loop for I in range 0 to y, just like we saw above. And now what I want to do is I want to add x to itself. So that would be x plus equals, instead of 1, I'm going to add it to itself, just like that. Okay, just like before, we will return x, and we'll call it done. We'll hope that this works. So I'm going to go ahead and just comment out this test, and we'll write ourselves a quick test for multiplication as well. So I'm going to do print multiplication, blank line, and then I'll just copy all of this stuff because it's all going to be basically the same. So x, we input a number, input a number. I'll call these things products now, product 1, product 2, and we're going to be calling multiply, multiply loop. So far, so good. And we're going to say multiply x times y, and then we'll see if our variables match. Prod 1 equals prod 2. So I went over that fairly quickly, again, just because it's very, very similar to what we've seen in the previous tests. Let's go ahead, hit run. We're going to do a test, say 3 times 2, and we got false this time. It did not work. So this is interesting. This is a little bit of a tough one to spot. I'll scroll up so you can see the functions as well. Now we don't have too much time left, so I'm just going to kind of give away the answer here. But if you look at this for long enough, you might realize that we are not adding x to itself y times. In fact, what we're doing here is we're adding x to itself y plus 1 times. Why is that? We started off with x as, say, in this example, 3. Now we're going to add 3 to 3 twice because y is 2. So we go 3 plus 3 is 6. And then we do it again. 3 plus 3 is 9. And that is not the answer we're looking for. So again, as with many things in programming, there's a lot of different ways to fix this. What I'm going to do, though, is I'm going to give us a new variable. So I'm going to call it prod, and I'm going to set it equal to 0. And then instead of adding x like this, I'm going to add x to prod. So now we start off at 0. If y is 2, we're going to do this twice, add x, which is 3, twice to 0, we should get 6. So, and actually one other small mistake here, I should not return x, I should now return prod. Go ahead and run this and see if it works. So we'll do 3 times 2. And here we got that our test passed because our functions agreed. Okay, so that brings us to the end of the calculator example. That one was much longer, many more functions, lots more to think about. I will pause here if anybody has any questions. And in the meantime, I'm also going to throw up the post-Zoom poll just to see how people are feeling now with the content. But again, if you do have any questions about the calculator example, feel free to throw them in the chat, and I will do my best to address them. Can you please scroll down a little? Yes. So this was the multiplication. You just barely can't see it all on the same screen. There we go. So somebody asks, when you add something in print, you can only use a string? Correct. So whenever we call this print function, the input has to be a string. Otherwise, you will get some kind of error. Actually, we can just do this to demonstrate. As I said, the best thing to do with programming is to just try it out. So I'm going to try print 1. as an example. Hit run. Oh, actually, it does work. Oh, there you go. I was mistaken. Yeah, so I guess you can pass in non-strings here as well. It'll still print it. It'll still work. Any other questions? So I know we are at time here. So you could do print x times y. I think so. Let's give it a shot. So say 3 times 2, just like this. If I hit run, it seems to work. Yes. So somebody in the chat points out it has to be all a string or all an integer. I think that would be a good way of thinking about it. Yes. Okay, so we are at time here. I am going to keep going with the optional example in just a moment, but just a closing comment before we do that. I think the biggest thing to remember with functions in Python is to try and relate it back to mathematical notation. So if you remember from before when we had those 5 questions, I said that when you write a function in math, you would normally have something that looks like f of x equals 2, right, as your output. Or you could even say like x squared, something like this. Functions in Python look similar. There's just kind of these extra bits that you have to remember. You have to remember def to define, and you have to remember return to give an output. Other than that, though, this format with the name, brackets, inputs, doing some computations with the inputs, and returning them as an output, all of those are very similar ideas. And so there is a reason why functions in programming share a name with functions from math. All right, so if there aren't any other questions, I will wrap up the required content there. So please feel free to head off if you have other things to do tonight, other places to be. But if not, I am going to keep going with the optional content, which is going to be Mad Libs, basically another project kind of like this. It's a little bit shorter though, just to do a little bit more practice with Python. So once again, feel free to head out. We're going to move on to the purely optional content now. If you do want to stick around and get a bit more practice with Python, then I will be getting started in about 30 seconds. If not, though, have a good night, and we'll see you next week. Code for attendance. Yes, it is right here at the top, 6720. 6720. Okay, so as people are filtering out, I'm going to remove everything we had for the calculator because we are now moving on to the Mad Libs project. Do you know if Q will have a more advanced quantum computing course next year? I don't. So we are certainly in the process of planning for next year, and we have heard this request come up, so it's on our radar. We haven't made any final decisions yet, at least as far as I'm aware, if there will be more offerings next year. But it's awesome to hear that you're interested. There is a lot more to learn in quantum computing. So yeah, we will see. Okay, I'm going to get started with Mad Libs. So there's actually no sample code or anything that I'm going to pull in for this. I'm just going to explain it verbally, and maybe I'll type some example stuff as we go. Now, a Mad Lib is something that actually has nothing to do with programming, usually. It's kind of like a word game. And so it might go something like this. Say, I don't know, I'll come up with a name. Tommy was a blank and enjoyed blank running to the blank. I don't know. And so the way that this works is this story would be hidden from you at first. So I'm just going to comment it out to pretend it's hidden. And instead, I would go up and ask you, I would say, can you give me some random noun? And then you would say, okay, I'll give you a noun. Apple is a noun. And then I would say, okay, how about an adverb? And you would say, how about quickly? Quickly is an adverb. And then finally, I would say, maybe a place. Give me a place. And you would say, I don't know, park is a place. right? And once you give me these three things, then the program will go into the sentence and replace, like put them into the blanks and print out the sentence. And the idea here is that usually, because you gave these noun, adverb in place with no context about what the sentence was, the sentence is going to sound really weird and funny when you eventually print it out. So in this case, you can see that the sentence would become, Tommy was a apple, which of course makes no sense, and enjoyed quickly running to the park, right? And so the Mad Libs program that we're going to write should ask the user for words without giving any other context, and then print out one of these funny sentences or stories back to the user. So let's get started here. I'm going to divide it up into two general steps. The first step is going to be to get words from the user. Oops. User. And then the second step is going to be print out the Mad Lib, or print out the sentence. So let's go ahead and give this a try. We already know how to get things from the user. It was that input function that we saw before. So I'm going to go ahead and I'll start off with a similar example to the sentence we just had. So the first thing we're going to get is a noun. So I'm just going to call it noun1 as a variable, equals input, and then I'm going to ask the user to enter a noun. And if you remember from what we saw before, what this input function does, it's going to print out our string to the screen. It's going to put the user's cursor right after the colon, wait for them to type something, and then once they've typed it in, it's going to store it inside that variable. So we got our noun. We're also going to want an adverb. And then we wanted a place. Input, please enter a place. Cool. That's step one, generally speaking. Now, step two was to print out the Mad Lib. So I'm going to do print. Now, what we had, it was, if I recall correctly, Tommy was, that's how it started. Tommy was a, and then we have noun1 here. Who, I kind of forget what it said, who enjoyed adverb running to the place. And then I'll just put a period at the end. Okay, so it's giving me an error. Oh, oops, it should have been place one. Yes. So actually, I'll just pause here just to show how I figured that out. You see there's a red outline that Replit gives us. If I hover over it, it says there's an undefined name, undefined variable, place. And so indeed, I made a mistake. It should be place one. And then it should be happy. Okay, so I'm going to go ahead and click run on this, see if it works. So please enter a noun. Our noun was apple. Please enter an adverb. Our adverb was quickly. And then place was park. Hit enter. Tommy was an apple who enjoyed quickly running to the park. There we go. So that is about what we wanted to happen. Now, let's say that we wanted to add another sentence, for example. We can totally do that because we've already started labeling our variables with an index. So these are all labeled as one. Now, maybe for our second sentence, we're going to have something like once at the blank, and this should be place one, Tommy would sometimes blank with the blank. So let's say that that's the second sentence we're going for. So if we go to part one, we want to get a few more words from the user. We already have place one. Tommy would sometimes blank. So this is a verb. Please enter a verb. And then last thing is another noun. So here I'm going to call it noun2. Input, please enter maybe another noun. There we go. Now I need to print this out. So I'll do the same syntax as before. Once at the, and then I'm going to say the place. So again, it doesn't matter if I use the variable twice, that's totally allowed. Once at the place, Tommy would sometimes, this was our verb, with the noun. And then again, I'll put a period on the end. Now, one mistake that you can sometimes make with this is you'll be writing out a big print statement like this and forget one of the plus signs. So just to show an example, I'll show what it does if I did that. It'll give me a red outline and it'll just say invalid syntax, which to be honest is not the most helpful error message. So in this case, what I would do is I would just look at this, try to compare it to a line that I know works and see if I can spot the difference. So here the difference was just that we're missing a plus sign in between the noun to and the period. So I will go ahead and click run on this. And we'll do just the same example. So Tommy was an apple, adverb, quickly, park. Now we have a verb. Let's say just play. And a noun. Let's say soccer ball or football. I don't know if anybody here is from not North America. So if I hit enter now, we should see both of our sentences print. Tommy was an apple who enjoyed quickly running to the park. Once at the park, Tommy would sometimes play with the soccer ball. So indeed, everything seems to be working. And just to drive the point home, we could have totally different things that we fill in here. So if anybody has ideas for what we can fill in here, feel free to throw them in the chat and we'll make our own little Mad Lib and see how it goes. So throw in the chat, see if we have a noun, any noun. Corbin, okay. Let's do it. Adverb. Slowly. I'm slow. All right. Place. Mall. Okay. Verb. Let's do a verb now. Dance. All right. I like it. And then finally, a noun. Last noun. What's it going to be? School. McDonald's. School. Okay. I'll do school. You ready? So we'll press enter and we should see everything printed out. So here we go. Tommy was a Corbin. That makes a lot of sense. Who enjoyed slowly running to the mall. Once at the mall, Tommy would sometimes dance with the school. So there you go. That's our Mad Libs program. You could run this as many times as you wanted. Try plugging a bunch of stuff in. Yeah, totally makes sense. So this is how it is with Mad Libs. If you've ever played them, sometimes they don't make a whole lot of sense, but that's okay. All right, so that pretty much brings us to the end of the Mad Libs program. You could imagine adding more sentences. You would add more inputs, add more print statements. Feel free to go off and have fun with this on your own. I think this is kind of a fun application. And as you can see, it's just a few lines of Python code. So with that, I will wrap up this lab. Does anybody have any final questions before we sign off for tonight? Okay, so if there's no other questions, we'll wrap it up there. As always, good luck with the homework. If you do run into any problems or weird error messages or anything, feel free to throw it on Piazza. Literally just copy paste it in, and we should be able to help you walk through what the problem is. So good luck. Have a good night, everyone. Thanks for sticking it out right till the end of the optional content. And I hope you have fun with this week's assignment with Python. We'll see you next week.